Hello everyone, welcome to Olympiad geometry. Let's continue our study of the Menelaus theorem. Let's see this example. Let ABC be a triangle. We can do this triangle first. Let X, Y, Z are points on the extension of segment CBC and BA respectively. XA, YB, and ZC are tangent of triangle ABC circumcircle. Proof X, Y, Z are collinear. So we need a circumcircle of the ABC. Let's just draw the circle first. And then we draw ABC. Notice that X, Y, Z are points on the extension of segment CB, CA, and BA. It actually doesn't matter which direction. It's either the extension or the reverse extension. But we know that X is on the BC line, and XA is a tangent of the circumcircle. So we draw the tangent first, and we know it's on the BC line. So the intersection point is X, and we draw I just put it here, so it would be ZC, and for the eventually would intersect at a point we call it Y. So we want to prove that X, Y, Z are collinear. So when we see that we want to prove 3 points are collinear, we know that we can use the Menelaus theorem. Right? It's actually the converse of the Menelaus theorem. So we want to use the Menelaus theorem, we need to write it down first. We start from the convex of the triangle. It's basically the triangle ABC, right? And XYZ would be the intersection line. So we start from a convex of the triangle A, and to the next intersection point, that's Z. So we need to prove AZ divided by BZ times BX divided by CX times CY divided by AY equals to 1. We want to prove this. Now we look at the ratio of AZ to BZ. AZ to BZ. We know that AZ and BZ is actually, A and B are the points. Let's see, we have ZA times, because ZC is a tangent, so ZA times ZB equals to ZC squared, right? And ZA equals to ZC squared divided by ZB, which means the first term, AZ divided by BZ, can be written as ZC squared divided by BZ squared. That means we want to find the ratio of ZC to BZ. ZC is here, and BZ is here. So ZC to BZ, because ZC and BZ are two lateral of the triangle ZBC, so ZC divided by BC equals to the angle reference to ZC, right? That's sine B. Here I write B, so we know it's CBA divided by BZ. BZ reference to the angle BCZ. Now we need to think about what is BCZ. BCZ, it's this one. Because the triangle ZAC is similar to triangle ZCB, right? They are sharing the same angle because this one the angle ACZ equals to angle CBA. ACZ, this angle equals to CBA, and they are sharing the angle Z, that's BZC or AZC. That means the triangle ZAC is similar to triangle ZCB, which means the angle ZCB equals to angle ZAC. Sine the angle ZAC equals to sine pi minus angle ZAC. And sine pi minus angle ZAC is actually sine A, right? ZAC, pi minus ZAC is actually sine A, which means we turn the AZ to BZ ratio becomes to the ZC square divided by ZB square. Here, ZC square divided by ZB square. And we find that ZC divided by ZB is actually equals to sine B divided by sine A, which means AZ divided by BZ, it's actually equals to sine B to sine A square. For the same reason, BX to CX, it's actually sine C to sine B square. And CY to AY equals to sine A to sine C square. And now we multiply sine B to sine A squared and sine C to sine B squared and sine A to sine C squared. We know this one equals to 1, right? Sine B and sine B, sine C and sine C, sine A and sine A. So this equals to 1. That means AZ to BZ times BX to CX times CY to AY equals to 1, which means the Menelaus theorem is valid here, and use the converse of the Menelaus theorem, we know that X, Y, Z are collinear. This problem is not very difficult. It's just very first we need to think about, we need to relate this conclusion of X, Y, Z are collinear to the Menelaus theorem. And from the Menelaus theorem, we know that we want to prove this equation, and then we look at each term. For each term, we know that the only relation we can get from AZ and BZ is ZC square equals to ZA times ZB. Then we replace 1, and then we want to know the ratio of ZC divided by BZ. So start from here. We need to understand that we always transfer the segment ratio to the sine of the angle ratio, right? And then we understand that it's actually related to the angles of ABC. And once they multiply them together, it's equals to 1. We prove this equation. and we use a converse of the Menelaus theorem, we can prove that x, y, z are collinear.